Integration rules. In this video we're going to go through examples of how to integrate various functions. Remember that integration is the opposite of differentiation and finds the area under a curve. So number one, to integrate 5x cubed dx, add 1 to the power, divide by the new power. So the integral is equal to 5x to the 4 over 4 plus c. Don't forget to add plus c. When you have a function made up of various terms, treat each term individually. So the integration of 5x squared plus 4x minus 2 dx, add 1 to the power, so you get 5x cubed divided by the new power, plus 4x to the power of 2 divided by 2 is 2x squared, 2 goes to 2x, plus c. Differentiating e to the x is just e to the x. So 5e to the x is equal to 5e to the x plus c. Differentiating 7e to the power of 3x dx. Well, that's 7 lots of e to the 3x and divide by the 3 plus c. Integrating trig functions. Well, the integral of sine x is minus cos x plus c, and the integral of cos x is sine x. So the integral of 3 sine x 4x is equal to minus 3 cos 4x, the bracket remains the same, then divide by 4, the differential of the bracket, plus c. So the integral of 5 cos 2x is equal to 5 sine, bracket remains the same, 2x, divided by the differential of the bracket, 2, plus c. And integrating 1 over x is equal to log x plus c. So the integral of 5 over x is equal to 5 lots of the integral to 1 over x dx, which is equal to 5 natural log of x plus c. Right, the integral of 4 over brackets 2x plus 3 dx is equal to 2 lots of the integral, I've just factored out 2 over 2x plus 3 dx. If we take a closer look at this, the numerator is the differential of the denominator. That means you get log of the bracket. So this is equal to 2 log 2x plus 3 plus c. Right, in this part of the video we'll look at the difference between an indefinite integral question and a definite integral question. In an indefinite integral question, you'll be given f dash x, which is the differential of a function. You'll be then given one other piece of information which will enable you to find c. So in this question we're given f dash x equals x cubed minus x dx, and we're asked to find f of x. Well, f of x is equal to the integral of x cubed minus x dx, which is equal to, add 1 to the power, x to the 4 over 4, minus x squared over 2 plus c. I will just move this up to give myself a little bit more space. We are then told that f1 is equal to 6. So when x is 1, f of x is 6. We can use this to find c. So therefore, 6 is equal to 1 over 4 minus 1 squared is 1 over 2 plus c. Therefore, c is equal to 25 over 4. Therefore, f of x is equal to x to the power of 4 over 4 minus x to the power of 2 over 2 plus 25 over 4. In a definite integral question, you are finding a numerical value. The integral between 1 and 3 of x cubed minus x dx is the area under the curve from x is 1 to x is 3 of the function x cubed minus x. So the first thing you need to do is integrate. So therefore we get the integral is x to the 4 over 4 minus x squared over 2 plus c between 1 and 3. It is very important that you put square brackets in this part of the question. The IB will take marks away if square brackets are not used. Therefore, substitute in, so we get 3 to the power of 4 over 4 minus 3 squared over 2. The c's disappear, minus 1 over 4 minus 1 over 2. Therefore, the integral is 16 units squared. It's nice to put units squared because it shows the examiner that you know that this is the area under a curve. If this occurs on a calculator paper, just use your GDC to find the definite integral. In this typical IB question, you're given the function f dash, a point it passes through, and are asked to find f of x. F of x is equal to the integral of 2e to the minus 3x dx. So f of x, if you integrate that, you get 2e to the minus 3x divided by minus 3 plus c. So f of x is equal to minus 2 over 3 e to the minus 3x plus c. You then use the point 1/3 5 to find c. So therefore 5 substituting for y is equal to minus 2/3 e to the minus 3 times 1/3 plus c. Therefore 5 is equal to minus 2/3 e to the minus 1 plus c. Therefore c is equal to 5 plus 2 over 3e. Therefore f of x is equal to minus 2/3 e to the minus 3x plus 5 plus 2 over 3e. This second question is a typical IB question that will appear on a paper 2. Let f of x equal x squared and g of x equal 3 natural log x plus 1. It's got a limitation for x must be greater than minus 1 because 3 log x plus 1 can't be less than 0. Part A, solve f of x equals g of x. So we want to solve x squared equals 3 log x plus 1, and to do that we're going to use a GDC. X squared equals 3 natural log x plus 1. First open a graph page. Draw your graphs. So x squared, enter. Let's move that out of the way. Tab to draw your second graph. So 3 times log x plus 1, enter. Let's get that out of the way. Now you can find you've got two sets of intersection points. You can find them all together. So menu, geometry, points and lines, points of intersection. Then touch one graph, then touch the second graph, and there are your points of intersection, 0, 0, and 1.74, 3.2. So our solutions are x equals 0 or x equals 1.74. In part B, we want to find the area between x squared and 3 log x plus 1. As we can see, if you quickly draw a diagram, that's a bit wrong, so let's do it again because it goes through 0, 0, and that's our point. X is 0 and 1.74. So we want to draw the definite integral, or find the area of the definite integral between 0 and 1.74 of 3 log x plus 1 minus x squared dx. To do this, we're going to use a GDC. A TI Inspire, open a calculator page, and then you want to open your little box there which gets all the mathematical symbols. You want your integral, so click on it, and now you can put in your two integral values. So one of ours is 0, the other one is 1.74. And in this box, type in your equation. So we want 3 log x plus 1 minus x squared dx, and there is our integral value, the area under that curve, 1.31. So the area under the curve is equal to 1.31 to 3 significant figures.